All right, hey everybody. My name's Rob Dzur. I'm with Bohannan Houston. We're an engineering company in Albuquerque, New Mexico, and I'll give you a quick window into how we use grass for some of our work with a product called elevation derived hydrography. So I'm going to take you back in time about a decade when we first started developing this workflow at scale. I'll briefly kind of go over the workflow. It all starts with a digital elevation model. And what we were doing here, we were in the midst of a large LiDAR project for Santa Fe County, New Mexico. And as one of the components, they wanted to get a depiction of where all the flow paths were across an entire 3,000 square miles. So people already said grass is powerful and grass to the rescue to help us do this. So once you start with a DEM, you can then compute a flow accumulation map with RDOT watershed. We did that on the way to extracting an initial flow network. And one of the things you notice here, we were dealing with a roadway, but we don't have a culvert. And so we, again, to model a culvert, we turned to grass and we used RDOT geomorphon. Here you see blues representing valley features. So we tried to connect the upstream location of a pipe where we had flow lines already established in blue and the corresponding neighbor to a downstream valley location directly across the road. This worked for us about 30% of the time. Not great when you have to do more than 2,000 culverts over 3,000 square miles, but still better than nothing. And so once we had the culvert in place, a cut line, we could build a hydro-enforced DEM, and then we'd bring it all back together with the original DEM using RDOT patch, and that would give us a hydro-enforced model that we could then reiterate the entire workflow. So we'd go back through the workflow, but this time we'd have hydro enforcement to convey the water through the culvert pipe at this location, which is an interstate. And that's what the client really wanted, to be able to have something logical for environmental applications, for housing permitting, to make sure they didn't permit houses next to a stream. So fast forward to today, we're not only repurposing the same Santa Fe County workflow in grass, we're repurposing the same Santa Fe County data. So why throw away good culverts if you've built them? So we are taking those culvert data, and here the innovation is that we are computing sky view factor imagery, that's scale, grayscale that you see on the screen, and we feed that into a deep learning model. You can compute sky view factor with RDOT Skyview, and then that model has been a real game changer for us. So our predictions of culverts on the landscape are now about 90% accurate. So that just speeds us along faster to get to the point where we're doing RDOT patch. So we don't have to wait so long. And we can produce a fully topological network through the workflow on a project like this. This is a USGS project that we're working on in Dolores Headwaters in Colorado. Another fun innovation on this project is automating what's called artificial flow paths. So here we have a reservoir. If you just look at the initial, and I didn't put it on the screen, but the initial flow paths really can't travel very coherently across a flat lake. And so here we're using VDOT Voronoi to compute a Voronoi diagram, and then we take advantage of GRASS's VDOT network analysis to compute the shortest distance from the incoming flow paths to the output, and it makes much nicer visual, and it's a requirement to have this, but most people do it manually. We're of course trying to automate that. If I look kind of towards the future, I can already say confidently, grass is a solid performer for us for this elevation-derived hydro, but what's great is it's not a static project. And so we're taking advantage of other innovations. You already saw the multi-core processing that Anna talked about. So we have that now in RDOT patch. So that helps us take advantage of the computing platforms we have. Thanks, Dr. Cho, for innovation in memory management, which is critical in hydrology. And so we are using RDOT water outlet.less memory to compute and update the basin geometry for the project areas that we're working on. And then there's the natural progression of technology. We run most of our work on the Mac platform, and that's a huge benefit for folks like us that want to try different platforms. Grass runs on the Mac, and so today on the latest MacBook Pros laptop, we can run a full Dolores Headwaters with 1,800 square miles at 1 meter resolution. We can do that in under 5 hours versus state-of-the-art equipment 6 years ago that took us 12 hours. So it's a fantastic platform. I think we're really poised to upscale our production and revolutionize our automation. So thanks to my team back in Albuquerque, folks at Santa Fe, our team on both projects at Aerographics, the USGS, and what we hear, we couldn't do this work without you. So thank you.